Scientists have installed 3 new temporary seismic stations to monitor a spike in earthquakes on Mount Adams.
A sleeping giant has stirred, and the ground beneath Mount Adams is telling a story scientists can't ignore. An extraordinary 800% surge in earthquakes has shattered the volcano's usual calm, sending shockwaves of concern through the Pacific Northwest. Could this be the prelude to an event that hasn't been seen here in thousands of years? From mysterious tremors deep beneath the surface to the astonishing evidence of magma on the move, the signs are as intriguing as they are unsettling. This towering stratovolcano, long considered dormant, may be hiding secrets that could reshape the region forever. What's behind this seismic anomaly? Is it a fleeting geological hiccup, or the first warning of something far more dramatic? Stay with us as we unravel the clues, revealing just how close we might be to an extraordinary natural event. Dramatic surge in seismic activity. Mount Adams has captured the attention of scientists and residents alike with a staggering 800% increase in seismic activity, as reported by the Cascadia Monitoring System and the U.S. Geological Survey, USGS. Typically, this dormant stratovolcano experiences only one earthquake every 1-2 years, but in a single month, 6 earthquakes were recorded, an occurrence far beyond its usual patterns. Ranging in magnitudes from 0.9 to 2.0, these tremors were shallow, occurring at depths between 3,000 feet above and just below sea level. Such activity is a sharp deviation from the norm, suggesting a significant shift in the volcano's behavior. One of the most concerning events was a magnitude 2.0 earthquake recorded at 1 kilometer above sea level, indicating ground elevation changes caused by subsurface forces. The earthquake's shallow depths point to potential magma movement beneath the surface, a hallmark of increased volcanic activity. Seismic experts have noted that such anomalies, while not definitive evidence of an impending eruption, align with patterns observed in other volcanoes before they became active. The sudden clustering of tremors only emphasizes the deficiencies in monitoring an active site like Mount Adams. The area chiefly relies on a single seismic station, ASR2 7 miles southwest of the summit, with neither redundancy nor support from other monitoring systems. The unusual activity has been picked up by this station, but because of its position, exact earthquake locations or the full extent of the unrest cannot be assessed. This kind of incomprehensive data calls for an urgent need to install more monitoring systems to keep track of these developing issues. Meanwhile, despite the seismic drama unfolding, Mount Adams, according to the U.S. Geological Survey, remains at a very low alert level, or green. But this will continue to have the eyes of experts looking for any other changes, since such surges can precede anything bigger in terms of volcanic behavior. Whether this is a short-term deviation or the beginning of a long-term change in dormancy by the volcano, the recent earthquakes are a stark reminder of the eeriness and unpredictability that the Earth's subsurface dynamics exhibit. The dramatic surge in seismic activity beneath Mount Adams not only raises questions about potential volcanic unrest, but also highlights the hidden immediate danger of lahars, devastating mudflows that can strike without warning, posing a far greater threat to nearby communities than an eruption itself. Hidden dangers. While Mount Adams' increased seismic activity is concerning, the most immediate threat to nearby communities isn't an eruption, it's lahars. These volcanic mudflows, composed of ash, rock, and melted ice, can travel with the speed and force of concrete, devastating everything in their path. Historical records reveal that Mount Adams has produced massive lahars, some of which transformed the landscape miles away from the volcano. Unlike eruptions, lahars can occur during dormant periods, triggered by seismic activity, glacier collapse, or hydrothermal events. One of the most catastrophic lahars in Mount Adams' history is the Trout Lake Lahar, which occurred around 6,000 years ago. Originating from the volcano's southwest flank, this event carried enormous amounts of debris downstream, covering approximately 15 kilometers of lowlands. The sheer volume of material created Trout Lake itself and left deposits up to 65 feet thick. Debris from this lahar traveled as far as Husum, 37 miles from its source, showcasing the widespread impact such an event can have. Such lahars, which stretched like this of one that last took place around 300 years ago, confirm that hazards have remained an imminent threat. Triggered by weakened rocks rather likely affected by hydrothermal activity, This flows down the southwest slopes of Mount Adams, recording parallels with the disastrous earlier flows. Less savage still avalanches and debris flows occur constantly near Avalanche Glacier, emphasizing further the volcanic terrain's unstable attribute. These reiterating processes remind scientists and residents of the mountain's inherently volatile nature. The nature of lahar flows makes them very dangerous. Most eruptions have precursor signs similar to earthquakes and concomitant seismic activity. On the contrary, lahars can come upon communities living downstream of Mount Adams when they least expect it, especially those that inhabit low-lying areas around rivers and lakes. Such communities increasingly require emergency preparedness plans in an attempt to avert damage to life and property. With all the increasing seismic activities on Mount Adams, such understanding must include how lahar flows are triggered and how they behave in an attempt to protect those residing under the long shadow cast by the mighty volcano. Interconnected volcanoes. Mount Adams is not an isolated volcano. It is part of the Cascadian volcanic arc, a geologically dynamic region stretching along the Pacific Northwest. Recent research suggests that volcanoes in this area, including Mount Adams, Mount St. Helens, and Mount Rainier, may share interconnected magma systems. This vast underground network of molten rock serves as a common thread linking the activity of these volcanoes, with movement in one potentially influencing the behavior of others. This interconnectedness raises intriguing questions about how Mount Adams fits into the broader volcanic system. Studies reveal that Mount Adams sits atop a massive magma reservoir with an estimated volume large enough to fill Lake Michigan 2.6 times. This immense chamber is part of a larger network that may also feed Mount St. Helens and Mount Rainier, connecting these volcanoes through deep subterranean pathways. While each volcano has its unique characteristics, the shared magma source highlights the complex relationship between these iconic peaks. If the pressure builds in one section of the network, it could ripple outward, impacting neighboring volcanoes. The Cascadian subduction zone ensures that the tectonic plates come together and serve as the engine to feed the connected volcanic system. The convergence between the Juan de Fuca plate and the North American plate generates sufficient heat and pressure to bring the rock to a melting state, producing magma. This becomes the basis for volcanic activity in the area, including that related to the new surge of seismic activity at Mount Adams. Understanding this interaction allows scientists to forecast the changes and the expected effects that each of the volcanoes in the system might bring. Mount Adams, therefore, lies as a connecting link in the network that emphasizes the need to monitor this volcano more as part of an activity profile coordinated by the famous Cascadian volcanoes, rather than in isolation. It may mean that magma movement under Mount Adams does not happen independently of its neighbors, thus necessitating tracking observed regional seismicity and volcanic activity. While there is ongoing work to understand more of these connections, these scientists are revealing the Cascades as an interconnected system with local and more distant impacts. Why Mount Adams stands out. Mount Adams, while often overshadowed by its more famous neighbors like Mount St. Helens and Mount Rainier, holds a unique place in the Cascade Range. As the second largest volcano in the Cascades by volume, its towering presence and sprawling glaciers dominate the landscape. Despite its dormant reputation, the recent surge in seismic activity has thrust Mount Adams into the spotlight, reminding scientists and residents of its potentially volatile nature. Unlike its more active counterparts, Mount Adams's long dormancy has lulled many into a false sense of security. What sets Mount Adams apart is its history of producing large, destructive debris avalanches and lahars, even during dormant periods. For instance, a massive landslide about 6,000 years ago reshaped the southwest flank of the volcano, creating the Trout Lake Lahar and depositing debris up to 65 feet thick miles downstream. Smaller avalanches and debris flows have also occurred more recently, particularly near Avalanche Glacier, which has seen several events since 1921. These incidents highlight the volcano's unstable terrain, a product of its heavily glaciated slopes and ongoing geological processes. This is yet another characteristic feature of Mount Adams. It literally sits above the regional magma system. While some other Cascade volcanoes have erupted frequently, the magma beneath Mount Adams is now thought to comprise a vast reservoir, which recent studies have proposed as one of the largest in the region. Although this magma system seems inactive, there are now signs indicating recent seismic activity, together with evidence of magma movement below. A recent phenomenon of shallow earthquakes points toward a potential passage from dormancy for Mount Adams into more active periods. Mount Adams is also different from other Cascade volcanoes in its lack of monitoring systems. Currently, activity is captured only via one primary seismic station, ASR2, which is located 7 miles southwest of the peak. All others remain silent. There also lacks a dataset that would be needed to adequately scale the recent seismic event and what can be associated with it. Mount Adams has historically behaved quietly, but measures, among other factors, have considerable size, unique hazards, and now signs of unrest emerging from below that demand close scientific scrutiny, great expectations, and improved monitoring. Mount Adams's unique features make it a standout in the Cascade Range, but its past holds clues that are even more striking and potentially ominous. What secrets lie buried in the volcano's turbulent history? Let's uncover the lessons it's left behind. Lessons from the past. Mount Adams' history is a powerful reminder of the destructive potential hidden beneath its seemingly tranquil surface. The volcano's last known eruption occurred around 3,800 years ago, with a prior eruption taking place roughly 7,600 years ago. While these eruptions were not as explosive as those of Mount St. Helens, they significantly reshaped the landscape, depositing lava flows and pyroclastic material. Even in its dormancy, Mount Adams has proven capable of unleashing catastrophic events, such as lahars and debris avalanches, which can occur without warning and with devastating consequences. One of the most notable events in Mount Adams's history is the Trout Lake Lahar, which occurred approximately 6,000 years ago. This massive debris flow originated from the southwest flank of the volcano and traveled over 15 kilometers, depositing material as far as 37 miles downstream. The lahar dramatically altered the region's topography, creating what is now Trout Lake, and leaving deposits up to 65 feet thick. This event underscores the sheer power of volcanic mudflows, which can travel vast distances, destroying everything in their path. About 300 years back, yet another important lahar crawled downhill from the southwestern slopes of Mount Adams, probably the result of disintegrating rocks from hydrothermal activity. Smaller slippages and debris flows have continued to occur close to the glaciers of the volcano, particularly Avalanche Glacier, where a number of events have happened since the early decades of the 20th century. Such small but frequent problems only underline the steep, glaciated slopes of the volcano's ongoing risks to adjacent periods of dormancy. Mount Adams' lessons learned include how volcanoes create a twofold message of risk danger. The extended periods of dormancy may make people believe all is well, but sudden geological phenomena can wreak havoc. History reveals that lahars and avalanches, which need not imply the arrival of magma to the surface, can be Mount Adams' most dangerous events. They are not necessarily eruptions, but are today linked to the increasing seismic activity as scientists garner ever more compelling evidence for magma movement beneath the volcano. Such reminiscences are crucial in the development of mitigation measures against possible future hazards. Limitations of monitoring. Monitoring. Mount Adams presents significant challenges due to a lack of sufficient infrastructure, which limits scientists' ability to fully understand and predict its activity. Currently, the primary seismic station near the volcano, ASR2, is located 7 miles southwest of the summit, with limited support from a secondary station, TRW, farther east. While these stations have detected recent seismic surges, the sparse network makes it difficult to pinpoint the precise location, depth, and extent of the activity. This lack of comprehensive coverage leaves critical questions about the ongoing geological changes unanswered. The limited number of monitoring stations also hampers the ability to track subtle signals that could provide early warnings of volcanic unrest. For example, slow-moving tremors and long-period seismic waves, both indicative of magma movement, require multiple data points to accurately determine their origin and implications. Without a dense network of sensors, these signals are harder to interpret, increasing the risk of missing key precursors to a potential eruption or other volcanic hazards. Another gap in monitoring is the lack of gas emission detection equipment at Mount Adams. Other than the gas monitoring systems at another Cascade volcano, Mount St. Helens, Mount Adams does not have the tools by which to measure volcanic gases like sulfur dioxide and carbon dioxide. Emissions would show or infer some magma activity or pressure changes at depth. Without these data, scientists are missing an important piece of the puzzle to judge where the volcano is now and what threats it faces in the future. The Cascades Volcano Observatory is just embarking upon this process of obtaining temporary seismic stations around Mount Adams for dedicated field deployment. Such rapid deployment packages have improved coverage and enhanced volcanic signals detection and analysis, but gaps will undoubtedly exist through the permanent and robust monitoring network not yet established to fill the gaps. This raises the urgent need for increased investment in such monitoring infrastructure that would deter communities under the shadow of this rather active volcano. Could this be a warning? The recent surge in seismic activity at Mount Adams, with a staggering 800% increase in earthquakes, raises a pressing question. Could this be a warning of impending volcanic unrest? Historically dormant and quiet, the volcano is now exhibiting signs of potential magma movement beneath its surface. Shallow tremors and long-period waves detected by seismic instruments suggest that molten rock may be shifting, fracturing the Earth's crust, and pressurizing underground pathways. These patterns, while not definitive proof of an imminent eruption, are consistent with early warning signs seen in other volcanoes before significant activity. One key indicator of potential unrest is the depth and location of the recent earthquakes. Many of the recorded events occurred at depths ranging from just below sea level to 3,000 feet above, suggesting that magma is rising closer to the surface. A notable 2.0 magnitude quake at 1 kilometer above sea level hints at ground elevation changes caused by subsurface pressure. These shallow tremors are often linked to magma intrusion, where molten rock pushes through cracks and creates pathways toward the surface, a phenomenon that has preceded eruptions in other Cascade volcanoes. Also, the massive magma reservoir that Mount Adams has is one of the largest in the Cascade Range. Studies conducted have shown that such a reservoir has sufficient magma to fill Lake Michigan to 2.6 times, thus telling us of the great capacity of this volcano to erupt significantly. Should the pressure continue building within this system, further seismic activities may follow or, in the worst case, even a volcanic eruption. But scientists caution that while much can be made by these signs, they do not necessarily spell good for an eruption. Such events unfold over years or even decades. Whatever way one looks at it, increased activity at Mount Adams is a reminder of what a volcano can mean in case of hazards. There can be lahars, avalanches, or even eruptions. There are threats to the nearby ones. More science and monitoring were required to differentiate myth from reality in these recent signals that could be transitory or might just be the starting stages of something greater. Right now, the coming unrest at Mount Adams is a clarion call to vigilance, for the Earth has hidden processes that often give only subtle hints before they explode into dramatic changes. The human element. The increasing seismic activity at Mount Adams poses significant risks to the nearby communities, many of which are unprepared for the potential hazards associated with a reawakening volcano. Although Mount Adams has not erupted in thousands of years, its history of lahars, avalanches, and other geological events highlights the importance of readiness. These hazards can occur suddenly, with little to no warning, leaving residents and infrastructure vulnerable. The recent surge in earthquakes is a stark reminder that even dormant volcanoes can present significant risks. One of the primary concerns for communities near Mount Adams is the threat of lahars, rapidly flowing volcanic mudslides composed of ash, rock, and water. These destructive events can be triggered by seismic activity, glacier collapse, or hydrothermal heating, and they travel with the speed and force of liquid concrete. Given the volcano's glaciated slopes, a sudden lahar could devastate downstream areas, including low-lying towns and farmlands. Past lahars, such as the Trout Lake lahar, have reshaped the landscape and caused massive destruction, underscoring the need for preparedness. Emergency preparedness is one of the main measures that should be used to mitigate the threats posed by Mount Adams. Local government authorities and scientists have tried to improve the existing early warning systems, which proved difficult because of the extremely sparse monitoring infrastructures in the area. The population near the volcano must have comprehensive evacuation plans, and there must be a greater awareness campaign to educate them about volcanic hazards. Preparedness measures, such as lahar evacuation routes and bettered infrastructure constructs, would lead to major lesser effects on future geological events. The main challenge is how to fund and implement such improvements. Mount Adams has recently awakened the attention of local people, as well as officials, toward possible volcanic hazard preparedness. A representative from USGS said yesterday that USGS records a continued green alert level, which denotes no threats of an eruption as of now. Eruptions may begin in weeks or even days from the moment a volcano is dormant. For this reason, making sure those living under the shadow of Mount Adams are all set for whatever the future may hold is to monitor continually, educate the public, and engage in the community. In addition to traditional preparedness measures, cultural and historical perspectives can play a critical role in fostering resilience among communities living near Mount Adams. Indigenous tribes, such as the Yakama Nation, who have ancestral ties to the region, hold valuable knowledge about the mountain's long history and its potential hazards. Their oral traditions often include accounts of past volcanic events, such as lahars and avalanches, offering unique insights into patterns of geological activity. Collaborating with indigenous groups not only enriches scientific understanding, but also strengthens community engagement by incorporating culturally relevant approaches to disaster preparedness. For example, using stories or traditional ecological knowledge as part of education campaigns can resonate more deeply with local populations, ensuring that the message of preparedness reaches diverse audiences effectively. This fusion of modern science and traditional knowledge could create a more inclusive and well-rounded approach to mitigating risks posed by Mount Adams. Cultural and ecological impacts of volcanic activity. Volcanic activity at Mount Adams not only poses geological and safety challenges, but also carries significant cultural and ecological implications for the surrounding region. Indigenous communities, such as the Yakama Nation, have long regarded Mount Adams as a sacred site, with oral traditions that often include accounts of past volcanic events. These stories provide a unique perspective on the volcano's history, emphasizing the interconnectedness of the natural world and human life. Incorporating this traditional knowledge into scientific research can enrich our understanding of Mount Adams's potential hazards while fostering collaboration with local communities. Ecologically, Mount Adams supports diverse ecosystems that are intricately tied to its volcanic terrain. The mountain's glaciers provide essential water sources for rivers and streams that sustain fish, wildlife, and agricultural activities in the surrounding areas. However, volcanic activity, whether in the form of eruptions, lahars, or glacier collapse, could dramatically disrupt these ecosystems. For instance, a sudden lahar could alter river courses, devastate habitats, and impact species that rely on stable aquatic environments, such as salmon. The volcanic phenomenon, apart from its immediate effects, can have long-term impacts on soil fertility and vegetation growth. Layering of ash from past eruptions of Mount Adams has nourished the soil and allowed forests and meadows to flourish, both of which are a key link in the chain of biodiversity. Although this is generally regarded as the natural process of destruction and regeneration, the unpredictability of volcanic hazards underlies the thin line in that process. Understanding the cultural and ecological importance of Mount Adams adds a keener edge to being prepared for human safety and to safeguarding the area's natural and cultural resources. The collaborative effort of scientists, local communities, and indigenous tribes can ensure the protection of both cultural traditions and ecological resources against the dynamic and erratic behavior of Mount Adams. As communities prepare for the risks Mount Adams poses, there's a bigger question at play. What does this unrest reveal about the untamed power of nature itself? The answer might change how we see the forces shaping our world. Let's take a closer look. Nature's unpredictable power. Mount Adams serves as a powerful reminder of nature's unpredictability, particularly in the Pacific Northwest's Cascade Range. While the volcano has been dormant for centuries, the recent surge in seismic activity reveals that the forces shaping the Earth remain active and dynamic beneath its surface. These tremors, ranging from shallow quakes to long-period waves, are signals of potential magma movement and geological changes. Even in dormancy, Mount Adams and other cascade volcanoes are capable of significant events that could alter the region's landscape and disrupt the lives of those nearby. Volcanoes like Mount Adams are part of a larger geological system driven by the movement of tectonic plates. The Cascadia subduction zone, where the Juan de Fuca plate slips beneath the North American plate, is the source of the heat and pressure that fuels the region's volcanic activity. This subduction process not only creates magma, but also generates seismic energy that can activate dormant systems. The interconnected nature of the Cascade volcanoes underscores how shifts in one area can ripple through the region, adding layers of complexity to the forces at play. Too much power is held by nature, which is too difficult to guess or comprehend by human beings. Technology has brought a lot of advancement, but predicting volcanic eruptions is more like impossible. There are warning signs like seismic swarms, magma movements, gas emissions, and even other signs formulated by scientists, but the exact time and size remain elusive. Such a situation can be found in Mount Adams, as it may be that the current activity is only a temporary anomaly or an early stage of awakening. Instead, readjusting the interpretation of these signals and preparing for any outcome is required while the underlying processes still remain beyond full comprehension. It is a tale of Mount Adams and its forces, a power great enough to move mountains but unpredictable in that it could trigger one in the form of lahars, avalanches, and long dormancy. The evidence of mighty power beneath the surface is held by peaceful landscapes, and it has recently shown how much has remained stirring at Mount Adams within an active seismic swarm. For all that humanity would do, nature would not heed the timestamp of its evolving systems. Hence, vigilance over what best can be done to respect nature's unpredictability and the investment of science and resources in understanding and adapting to such forces would be advised. Staying one step ahead. The recent surge in seismic activity at Mount Adams has underscored the critical need for improved monitoring systems and preparedness strategies. With only one primary seismic station, ASR-2, located 7 miles southwest of the summit, the ability to detect and analyze volcanic signals is limited. Additional temporary seismic stations are being deployed by the Cascades Volcano Observatory to bridge this gap, but a permanent and robust monitoring network is essential for long-term safety and effective risk assessment. One major area of advancement lies in gas emission monitoring. Unlike other Cascade volcanoes, Mount Adams currently lacks the tools to measure volcanic gases, such as sulfur dioxide and carbon dioxide, which are key indicators of magma movement and pressure changes. Integrating gas sensors into the monitoring network would provide a more comprehensive picture of the volcano's activity and offer earlier warnings of potential unrest. This technology has proven invaluable at volcanoes like Yellowstone and could be a game changer for Mount Adams. Public education and emergency preparedness planning must be prioritized in addition to the enhancement of monitoring systems in those communities located near Mount Adams. Clear evacuation routes, hazard awareness campaigns, and real-time communication systems are right at increasing risks should an event occur. Previous incidents, such as the Trout Lake Lahar, showcase just how catastrophic one of Mount Adams' hazards can potentially turn out to be even in the absence of an eruption. The learned articulation of risk against which residents have to respond could save lives and reduce property loss. The role of rapid response systems in monitoring Mount Adams cannot be overstated. Portable seismic stations, drones equipped with thermal imaging, and satellite-based ground deformation tracking are just some of the new innovations that provide real-time insight into the volcano's behavior. With these small extensions, scientists can detect subtle movements in the elevation of magma and the ground, an invaluable and critical step toward improving early warning capabilities and refining hazard modeling. Mount Adams retains the powerful aura of nature's unpredictability and vigilance against potential volcanic hazards. True, the renewed surge of seismic activity raises concern, but it is also an opportunity to advance monitoring technologies, make preparedness stronger, and create better awareness of the forces beneath our feet. Combining cutting-edge science, community education, and proactive planning, we can minimize the risk of dynamic adaptation to the challenges posed by this towering giant. The future, then, is in staying one step ahead, in making sure that when nature speaks, we will be ready to listen and respond. And there you have it. Mount Adams is making some serious noise, and the Earth is shaking like it's had too much caffeine. Is this the prelude to a fiery show, or just another geological hiccup? Only time will tell. Whether this is a fleeting anomaly or the early stages of something far bigger, the message is clear. Mount Adams is stirring, and it's a powerful reminder of how dynamic and unpredictable our planet truly is. If you found this video intriguing, don't forget to like this video, comment your thoughts below, and subscribe to stay updated on Mount Adams and other fascinating stories. Be sure to click on the next video shown on the screen for more mind-blowing discoveries and breaking updates. Stay curious, stay prepared, and we'll see you in the next one.